So if we have three numbers A, B and C, which we say are proportional to the direction ratios of a line, then we can find out from those the direction cosines of the line. How is that? Suppose A, B and C are the direction ratios of a vector, that is they are proportional to the direction ratios of a vector. When we say A, B, C are direction ratios, we mean that they are proportional. Okay, so it becomes a bit lengthy to say that A, B and C are proportional to the direction ratios of a line. So we just say that A, B, C are the direction ratios. Okay, but when we say that they are the direction ratios, it is understood that they are proportional to the direction ratios. So if A, B and C are such the direction ratios, then the direction cosines can be obtained by plus or minus A upon square root of A square plus B square plus C square, plus or minus B upon square root of A square plus B square plus C square, plus or minus C upon square root of A square plus B square plus C square. Why is that? Why not something else? Because when we square them and add them, they become 1, which is proof that they are the direction ratios, the direction cosines, where if you have positive on one, then you take positive on all of them, or if you have negative, then you take negative on all of them. Mind you, the individual signs of the numbers A, B and C will still be retained. So if you're taking negative on all of them, however B happens to be a negative number in the first place, then the middle direction ratio corresponding to the y-axis will be positive. It's not that the signs are uniform, it's just that the signs outside the general ratio are uniform, not overall. So in many questions in three-dimensional geometry, we are given three numbers and they could either be the direction ratios or the direction cosines of a line, and many times, initially at least, it is confusing to identify whether they are, just by looks, whether they are direction cosines or direction ratios. So a simple test would suffice to indicate to you whether they are direction cosines or direction ratios. Generally speaking, direction cosines will be in ratio form, whereas direction ratios will be in whole number form. Another way to identify them is to put them in the form xi cap plus yj cap plus zk cap, square them and add them. If the sum of the squares add up to 1, then the numbers indicated are the direction cosines. If they are not, then they are proportional to the direction ratios. Another important result on direction cosines and direction ratios: if r bar is equal to ai cap plus bj cap plus ck cap, then its direction cosines are a by root a square plus b square plus c square, b by root a square plus b square plus c square, c by root a square plus b square plus c square. That is a divided by magnitude of r bar, b divided by magnitude of r bar, c divided by magnitude of r bar. So far we've been discussing about direction cosines, direction ratios of only a point which is joined to the origin. What if we are given something that is non-origin type of point? What if we are given 2 points whose coordinates are, say, x1, y1, z1 and x2, y2, z2, and how do we find out the direction cosines and the direction ratios of such a line? So the procedure is exactly the same. In fact, it is a generalization of whatever we have been discussing till now. Let's look at it. The direction ratios of the line segment joining the points x1, y1, z1 and x2, y2, z2 are proportional to the difference of their respective x, y and z coordinates. That is x2 minus x1, y2 minus y1, z2 minus z1. Two parallel vectors have proportional direction ratios. Yes. And of course, they'll have exactly same direction cosine values. Parallel vectors will have proportional direction ratios, but they will have exact same direction cosines, right? Why is that? Because they are parallel, they make the exact same angles with the x, y and z axis. So therefore, there is no question of direction cosines being different or proportional. The direction cosines have to be exactly equal to each other. L1 will be equal to L2, M1 will be equal to M2, N1 will be equal to N2. If a vector r bar has direction ratios proportional to a, b and c, three numbers, then r bar is equal to magnitude of r bar divided by square of a square plus b square plus c square under root times ai cap plus bj cap plus ck cap. So this magnitude of r bar divided by square root of the sum of the squares of a square b square plus c square is the unit vector. ai cap plus bj cap plus ck cap. Unit vector multiplied by those will give us the full vector r bar. If L, M and N are the direction cosines of a vector r bar is equal to xi cap plus yj cap plus zk cap, then its projections on the coordinate axis are respectively Lr cap, Mr cap and R cap, all magnitudes only. Let's look at a question based on this. Find the direction cosines of a vector r bar which is equally inclined with ox, oy and oz, that is the x, y and z axis. If magnitude of r bar is given, find the total number of such vectors.